Hello and welcome to another We Are Developers Live. It's Wednesday again, and we are here. I'm wearing a checkered shirt, which I normally tell people never to do because on cameras that can actually be a bad thing, you know, like the war effect kind of thing. But this one seems to be okay. How are you doing, Dan, today?
Yes, I'm all right. I didn't wear my bright green T-shirt for the same reason. You know, I was going to put my green screen up, and then I thought I'd just be a floating head. So, yeah, you got to think ahead for these things. But yes,
Wasn't there one time where the Queen was wearing a green thing at an official thing in her coach, and people put like pizzas on there, and it was just like, yeah, pretty hilarious.
Oh yes, I'll definitely be cutting that into this video because there's some absolute classics out there for that.
Yeah. And I mean, it's amazing. You put so much effort into putting your background with your guitar and your lights, and then you blur it.
I know, and it's cropped like this as well.
Yeah, but weird, like weird.
I just like depth of field.
Oh yeah. I mean, that's one of the easiest algorithms to actually simulate. So that's let's not talk about that stuff. But we have a lot of people today here who are going to talk about algorithms and computing and all the cool stuff again. This is a special edition of We Are Developers Live because we got one of our customers, friends, not customers, they're actually people that we had on the show before and we had in other pits before, and it's SciChart. So we got David Burleigh and we got Andrew Burnett-Thompson from SciChart both here. So you're both in England as well.
Hello.
And yeah, what's going on? Cool. So you just came. I thought you'd be much more droopy-eyed and tired because you released a new version of your product yesterday or today.
Yeah.
You know the old adage of don't deploy on a Friday. Well, we decided to do the deploy right before this this live stream. So, but it's there, it's live, and it's working. So that was SciChart.js version 5, huge update, and we'll be talking about that a bit later.
How much code is that? Like, how much is it to release the whole build for it?
It's been, I mean, we've been working on this release for about 4 months, and yeah, I mean, the last kind of 20% of getting from we're done to we can actually release is like a month's worth of work for, you know, demos and docs and release notes and
so on and so forth,
test and polish and all of that kind of stuff. So yeah, the last 20% is a killer.
Yeah. I mean, that's always the same thing. I mean, this Pareto principle is like 80-20. Same with like when you do like AI generated code, it gets you 80% on the way there, and then 20% is fixing it and arguing with the bot to not do things the way it did it. But yeah, it's the interesting bit. Same with like, I mean, I always hate when people bring up these, that's that principle or that's that thing. And you're like, yeah, okay. But also when it comes to contributions, there's always like 20% that bring in 80% of the outside contributions. It weirdly enough always gets out. But I'm not going to talk about data and insights with you because that's going to be embarrassing because you work on the big charting library that actually works with data. So we're going to go back to that later, but we're going to go to the scheduled programming today and just talk about a few things that I found lately that I wanted to chat with you about, which is the first thing is a malicious VS Code extension again. 1.5 million installs, steals developer source code and sends it somewhere to China. And it's basically, it's ChatGPT, ChatMOS. These are the two installs that you should not be using. And I guess the general idea is if something sounds too good to be like, hey, this is a free version of this expensive thing, it's probably not a good idea to actually install it. Then again, if you only work on open source, you kind of don't care if it gets sent to another server in the background, but at least it's a very bad idea. And I'm worried about this. Like, as somebody who cares about security and privacy and also code that should not get out into the world, a lot of people are now using editors that are 100% connected and everything is uploading it somewhere else and installing it somewhere else. I mean, we had another case a few weeks ago where just formatters, code formatters were stealing information from people. So how is it in your case, like in your company? What editors do you use? And do you use third-party stuff that might be leaking things, or do you have a stronger hold on it? David, what do you use?
We're relatively careful. We researched very carefully before we jumped into the AI code assistants to figure out like which one of them was going to actually, protect our source code and things like that. So, but actually there are good solutions to that out there. Claude and Anthropic and those API keys, the terms of service are pretty good in terms of what they will do and not do with your data and stuff. So yeah, that's pretty good. But it's really challenging from a source code point of view, and even from an interview point of view. I had a friend of mine who was saying that they had someone pass 3 rounds of video interview that ended up being a North Korean agent and got in and stole their stuff because they were like AI replacing their voice and video.
Okay.
So
wow.
Scary.
I mean, yeah, the whole job market. We have a thing this afternoon as well about branding, and it's really tough for companies to actually know if somebody is real or somebody is there. I mean, I had companies that offered me an interview and then said, talk to our AI assistant and do an interview with that person. And I'm like, how about no? And I go work somewhere else. Yeah. If you can't be bothered to give me a person to talk to, that's just bonkers, isn't it?
Yeah.
But yeah, it's going to be trickier to do. And I mean, this is an interesting one because I just had that as well. So I'm jumping ahead a bit. This came out last week, I think, the Qwen 3 TTS. That's a Chinese model, AI model, and it's this is basically a playground on Hugging Face, which allows you to synthesize voices, but to also clone voices. So you can try that out yourself, and I did it earlier and uploaded it to social media and a few things, where you can record yourself saying something, and then you give it the reference text of what you said, and then you give it another text to actually speak, and then generate it, and it generates it on the fly for you in that sandbox there, and then it actually makes you sound like you do, and it's pretty much spot on. And it's an open source model. I mean, there's a company that does that for a living, that does synthesized voices, and it's really expensive to do. But this one is now an open source model that you can run locally as well, and actually generate your own voice and stuff. And it seems like nothing is real anymore. So that's really fascinating to see. But I love that also Hugging Face gives you this this playground to actually do it there. So rather than burning your own CPUs and GPUs, it actually does it in the background for you. It takes about 30 seconds. But yeah, it's quite impressive what these things can do and how specialized they are by now. Of course, probably used by worse people on the planet out there. But then again, if I don't feel like speaking anymore.
I thought your example though, Chris, was kind of you hit the nail on the head about kind of how it's impressive, because to give you the context, Chris's example, you said something like, my name is Chris and my voice is my password, which a lot of us use for online banking. And then it's the fact that took you 30 seconds to do. It was so convincing, and it really hit the nail on the head of it's impressive, and you have that thought at first, and then you straight away think, this is quite dangerous. This could be used in really negative ways, and unfortunately it probably will, and that will be the things we hear about more than someone using it for something quite useful. Very cool tool though, and I hate to say that,
And the deep cut there is, of course, that my voice, my password, verify me is from Sneakers, the movie, which is one of the best hacking movies I know. Other than War Games, those two are really what it was like, and what it was, what the thing was, how we hacked in the past, that we went through people who did hacking, how they worked in the past, that they went through people's garbage to find information and all kind of stuff. It's all in that movie. And it's filmed in the same office that Mozilla was in San Francisco. So when I worked there, I was like, oh, this is so cool to be here. So yeah, that's how I was geeking out about this. But yeah, it's interesting that voice is not a safety mechanism anymore. Maybe a two-factor authentication, but not the main one at all. Cool. Other than that, amazing news. jQuery 4 is out. Uh-oh.
J what?
Yeah, it's still, it's still the most used JavaScript library out there because it's bundled with WordPress. So basically, if you look at HTTP Archive, it's still in everybody's computer. And they did a huge upgrade, and it's interesting to see that. And in things I wouldn't have predicted in 2026 to get as news headlines, jQuery 4 is out.
Yeah.
No idea what's changed. IE11 support removed. That's good. But yeah,
it looks like it's cleaning up. Looks like a lot of it is just cleaning up, like they're saying there, old APIs that aren't being used. I think that's probably what it needed, I guess. I mean, I don't know what it's sort of aiming to do at this point. Obviously, it's a project that's going to continue. You know, like you said, it's bundled with WordPress. It's not going anywhere. But I don't see many people, picking it up as something new that they think, oh, I've always wanted to learn this, even though it's useful.
I mean, it got a lot of people into development. It empowered a lot of people to get started without understanding JavaScript. It also got a lot of people with no knowledge whatsoever think they're developers. And actually, it had a lot of like horrible best practices or like these, like just use this and don't think about it idea was the thing that always drove me nuts. Like I talked about event delegation back then and performance, and then and this was like, okay, just run roughshod through the DOM, assign event handlers on everything, and then somehow it will be cleaned up in the future. It's that's how it felt like. But a lot of people got into it, and I guess Dan, you as well. Like you were one of those filthy
when you were saying
users.
that. Yeah, I was.
Yeah.
But I was very, everything you were saying about it, I was thinking, yeah, that really does describe me, because when I was, using like the first CMSs that I was using, things like WordPress, it was the little nuggets that I could see outside of the PHP that you've got access to in WordPress, but it was the little nuggets of code that I couldn't read. I couldn't read any of it, but I could find enough of it online at the time. There were these snippets being shared, and there was a good sort of community of people sharing these snippets. And exactly like you described, I had no idea what the code did. I just knew what the function was supposed to achieve. So then copy and paste straight into my project. And for years, I pretended I was, it made me feel like I was a developer doing that. So yeah, that describes me.
Cool.
I think now, we have at least 2 versions of jQuery on our website. And that's one of the issues with it, isn't it? Is that you can have these versions, but I'm pretty sure it's used everywhere, right? I mean, we're using WordPress as well.
When Teams came out, Microsoft Teams, we were wondering why it was so slow, and it ended up there's like 3 different XML parsers in there that were basically battling each other. It's a classic case of like engineering having to ship something really quickly and just add another one. It's got to be better. Like it's the mythical man month revisited. Now, WebAssembly is going to be a big thing that we're going to talk about later on a bit as well. Like what you're using in your environments. And I saw that article to get us into the mood a bit about WebAssembly was JavaScript testing side-by-side performance. And yeah, I was kind of disappointed by it, because it's like, here's the obvious thing to see. It's, WebAssembly is faster if you do things like image manipulation in JavaScript compared to image manipulation in WebAssembly. I mean, WebAssembly is not actually executed on demand, whereas JavaScript always is. So when you do something, when you have something that actually gets turned into binary code, so the computer doesn't have to do any translation anymore, it's of course much faster than the thing that needs changing all the time. So the time lost is when you actually have to convert it to bytecode and when you have to put the build things on top. But it's always going to be faster. And there's also the state of WebAssembly, what's happened in the last few years, like how it's now supported in all the browsers. So if you want to read more up on that and you want to get into WebAssembly, this is a really good idea of what the playground is like and which things you're gonna hit, which snags you're gonna hit. Now, David, when it comes to support, where do you draw the line? How do you make sure that the stuff that you're using WebAssembly and WebGPU for is supported? Is there a tiered approach that it gets a worse performance on another machine, and when it's available, it uses what it can, or how do you do that?
Yeah. So partly it's about picking APIs and things that are well supported. Things that have been challenging are content security policies, that some customers like to run ultra secure CSPs, which block WebAssembly and stuff, and we've had to tune our build parameters to sort of turn off some of the dynamic things that in scripting by default will fill your JavaScript with evals in order to to do dynamic loading, which is generally not fun. But one of the big ones that we hit in the JSV5 release, part of it is we have turned on WASM SIMD, so single instruction, multiple something. We get this doubling of speed basically for our the heavy math stuff. But the way that works so not all browsers and WebAssembly implementations support it. And if it's not supported, you don't get any kind of nice crash, any kind of nice error or detection or anything. It just dies completely.
Yeah, you can't catch the error. It's completely different to say, so SIMD, single instruction multiple data, allows you to basically put 2 doubles or 4 floats into a single register. And then when you multiply the 2, it's all done in essentially one instruction. Yeah, there is some latency and so on and so forth. So yeah, you can get 2 to 4 times faster performance for maths, which is great. If you make a binary on Windows and C++ using SIMD, as long as you auto-detect, do I have this hardware support, if else, and then use a scalar path or not, you're fine. But it turned out for WebAssembly that actually you can't load the binary at all. You can't even load it. It just simply fails. So there was I can't remember the name of it, but there was an NPM package provided by Google, which is WASM feature detect. And that's about 5-10 lines of JavaScript that just loads the most minimal binary for WASM. And if that fails, you catch that in JavaScript. And then you can feature detect. So we've done that in our latest version of SciChart JSV5.
Yeah, so
we're doing the auto detection.
WASM.
Right. So we're shipping 2 versions of the WASM, one for SIMD, one without. WebAssembly is actually supported all the way back to Chrome in 2017. If you have a look on Can I Use, the same as Edge, Safari back to 2017, Firefox, etc. So it's pretty much on 97% of browsers. But WASM SIMD wasn't. It was a little bit lower, 85, 90% of browsers. So we felt the need to do a little bit of auto detection there.
I remember
really excited about the what's coming up in WebAssembly, the version 3 stuff. Garbage collection in there is a huge thing. The memory model in WASM is one of the sort of struggle points at the moment.
We're really keen to try out WASM 64 as well. So we haven't done it because all of your pointers in WASM at the moment, by default, they're in 32. So that kind of limits you to a 4 GB address space. And we found a flag in the compiler that would go from the default 2 gig to 4, which is great, just by removing the sign bit. But there is another flag in the compiler to say, okay, we're going to have 64-bit. And then your maximum address space is up to, I think it's number.maxSafeInteger, which is something like 16 gigabytes. So you're never going to get terabytes of data in WASM as long as there is only number in JavaScript. But that's really neat. That's something we want to try out, because one of the things we found moving from, say, native code on Windows through to the browser was that really heavy scientific applications, they're like, hold on a second, I can't use more than 2 gigs. What do you mean? So that's an area that WASM is pushing. And for us, it's really cool that this is being supported by, used by, giants in the industry. I can see Google's heavily involved in it. You've got companies like Figma using WebAssembly, et cetera. So I think it's only going to get better. It's a cool technology.
Yeah, I mean, the only thing is insight, and debugging is an issue, isn't it? A lot of it becomes like a black hole that you don't know why it doesn't work.
We can't debug at all. I mean, luckily, the C++ code, we can run that natively on Windows and debug it that way. But we're back to the old days of console.log, print line, and you've just got to be, kind of an old school developer to work with something like WASM.
Yeah. One thing that was amazing me lately is also that when it comes to embedding binaries, have you seen this? This is actually Linux running inside a PDF.
Blew my mind.
And there is an instruction how to do that. Yeah, it's like it takes about a minute to boot up, but then you have a full Linux version running inside a PDF document inside a Chromium browser.
That is insane. I can't believe it.
I think they've also, the same person made Doom in a PDF as well. You can play Doom.
Yeah.
Yeah.
Amazing.
And there was Doom in TypeScript types. Did you see that one?
Yeah, and on an electric toothbrush. I mean, we always have like the maker of Doom at our event, and I was on stage with him a few times, and it's just hilarious. It's the new, like, it used to be, can it run Linux? Now it's, can it run Doom? And it's like, but this is just, it just shows how it just shows how dangerous PDFs are, because there's all kind of stuff that can happen in the background there, even in like font binaries and these kind of things. So it's actually quite fun that you can look it up and you can just read how they've done it with like the source code and everything written up. So it's pretty incredible, but yeah, also bonkers. So we're moving on a bit faster. I'm jumping on a few things. One thing I'm really excited about, I worked on Microsoft on documentation a lot, and they have a high-performance search engine in Rust and WebAssembly right now for searching through documentation. So you built your own AI bot thingy for your documentation.
Yeah,
this might be a fun thing to get to try out
that
as well.
Super cool. Yeah.
Yeah, especially as it has.
I can see there being a general purpose solution for this, if I'm honest, in the future. Like what we found, we have hundreds and hundreds of pages of documentation for our software library, and people were asking us questions, and essentially me, myself, our team, we were the LLM. We were looking stuff up and composing answers. So we just thought, come on, this has to be possible. So yeah, we built our own tool internally that would scrape all the docs, put them into a database, and then pull those out. But I can see this becoming a thing in the future. Like any website, find this. How bad is search? Everybody expects it to be like Google, and like everyone forgets that Google is $1 trillion company, and it's harder than it looks.
Yeah, and everybody thinks that like these companies have lots and lots of engineers on the back end call to do these kind of things. Like the docs team that I was on was like 3 people, and we had no budget, and we had nothing. So people were like, the outside contributions never came in because people thought, first of all, they're not good enough for Microsoft, or second of all, why should I do something for free for a company that has lots of people that they pay for? But no, our engineers are a rare resource as well. So not our
exactly. I mean, we don't even have a docs team. Our developers, it's part of the job. It's like you're writing the code, you have to make the examples, you have to write the docs, and then it comes down to using the right tools to make that easier. So we actually migrated to Dockersaurus. I think it was about a year ago, just because then you can just compose the docs in Markdown and put them in GitHub, and all of a sudden devs were like, oh yeah, this is great. This is not like writing Word documents, which they found tedious. It was Markdown,
I found myself writing documentation first, and then the code taught me a lot about not writing code that's unnecessary. It's
kind of like TDD. Doc-driven development.
DDD, like 3D. No, and that's just not good.
We had a very good instance of that in V5. We introduced a couple of new axis types, and they were all done, and it was all finished. And then we were writing the documentation, and in the process of doing that, we were like, this doesn't. It's like, it's confusing as we're writing this. This thing it's not named right, and you can tell because when you try and explain it, it's wrong. And so we renamed the whole thing to discontinuous data access. So it's now like, you know what it is, and suddenly then the documentation flows and makes sense, and you go, okay, that's when you know you've got a good API and things, when you can write the docs and you don't feel quite so bad about it.
Yeah, as library developers, I can say that library development is completely different to, say, application development as a challenge. And we have to think internally and sort of train our team to say, hey, come on, you've got to think like, how is this to use as a user that doesn't know this code? So that API has got to be clean, self-explanatory, intuitive, the pit of success principle. And writing docs, it's tedious, people don't like it, but it's kind of like the first line of dog fooding, writing docs and demos and examples. And whenever we do that, we always find issues like, oh, this doesn't work. If I do it like this, it doesn't work. I thought it would, but it doesn't. So it's a great exercise to make your software better,
Yeah, and also, I mean, how do you deal with feature requests? I mean, that was the other issue that we had. Like, people always want a feature because they want the feature, they don't have a use case for it. So you build something that is really heavy and really takes ages to do, and then you look at the numbers and your manager asks you how many people are using that stuff so that it was worthwhile for engineering time to be put on it, and you have like one user, or even that person just tried it out and wanted to have it. How do you deal with that kind of requests?
I mean, that's a really tough question to answer, but I'll tell you what we've learned over sort of like 10, 12 years of experience of doing this. Is that, yes, you're going to get a lot of feature requests. If you're an open source developer or if you're a commercial application developer, people are going to come to you all the time and say, we need this. And if it's commercial, you know, it's sort of like more, in fact, the onus is on you. You know, no one's going to submit a PR to help you. The onus is on you to do this. I guess you have to evaluate that feature as, is this useful to other people? If not, if it's only useful to one person, is there a benefit to making that person happy? You know, we want to keep all of our users happy, but it's impossible. We actually vibe coded. We were talking about AI earlier. We actually vibe coded a roadmap application that's internal, so that we can put all of our feature requests in there and then log who requested them and what was the potential value of them, and then schedule that onto a nice little timeline. You know, just shows the power of AI to knock up simple, not complex applications that can assist you in your business. Yeah, and then I guess more and more customer touch points. So, you know, at the moment we're going through a phase of not only surveying customers, but we're having calls with them, we're meeting them one-to-one to talk about their needs. Because sometimes if someone emails you and says, hey, we need a feature where, you know, if you click here on a 3D chart, it does this, yeah? We think, okay, you know, fine, fair enough, that sounds odd. But when they show us the application and they see, because we're building this, and that would unlock this value for our users, right? Then it becomes so clear. So I think the human interaction, the person-to-person communication is super important in order for us to understand the value of these features, if that makes sense.
All right, let's move on and actually see what it's about. So I open the web page here. You have a marquee running. I want to have a DHTML analog clock that follows the cursor around, but you don't have that one anymore. So talk us through what's happening in SciChart and what the V5 version is like. What are you super excited about that you changed? And I guess I can hand over to you to show your machine as well, because my Mac's gonna die.
Yeah, go ahead. I mean, so SciChart is we're a small independent business. We were founded in roughly 2011, and it was something that the initial version was coded by myself, literally on the commute to work. It was published and went online. It started to sell, and then we hired more and more people. And here we are. So, we have versions of our library we started off with Windows, WPF, then we built a version for iOS and Android, in native iOS and Android. And more lately, in 2019, 2020, we developed this version in JavaScript. So SciChart.js is a high-performance chart library. It's designed to handle extremely big data. It's designed to handle very, very complex use cases in sort of mission-critical applications, whether they be in industry and finance, in medical, this kind of thing. So we have companies out there who have a factory or a process, and they've got 10,000 sensors in their factory sending data to a machine that's being stored in a time series database, and they want to pull that out and do visualization and analytics. And there's not really easy ways to do that. When your data is so big, how do you visualize it? If you just throw it into SVG or into Canvas, your chart library is going to choke. So that's really the rationale behind SciChart, but it's not just about speed and performance. It's also about covering all of those edge cases, all of that flexibility that you need to build those really, really complex applications. So I was going to show you guys, first of all, that you can go on the webpage and you can read about it here. But we've actually got a live demo, which is at demo.scichart.com. And in here, we have 150 examples of SciChart for JavaScript, React, and Angular. So I'm looking at the React ones here, and you can see the kind of things that we can do. So for all intents and purposes, it's a chart library, like ones that you may be very, very familiar with. There's lots of open source libraries, lots of commercial ones. But the difference is using WebGL, using WebAssembly, and a focus on not only high performance, but also a really refined API to let you do these kind of tricky things. I've got a cool demo here. This one is the audio analyzer demo, which actually is picking up the voice from your microphone and transforming it into a time series at the top. We've got a Fourier series down at the bottom, and then we've got a Fourier spectra, which is a history of your frequency domain in the bottom right. This is all running in the browser. It's running live. It's very, very high performance, as you can see. So yeah, that's the kind of thing
we could mix that with that cloning AI thing to basically record and then play it back.
Yeah, you can see the waveform and see the little artifacts to go, it's not really them, or I don't know. Yeah, we do live in a crazy day and age, don't we? And I think all of us.
I mean, the fun thing about those is like you see them in sci-fi movies and you see them in TV shows, and it's all like the Dan Cranny world here. Like it's all the After Effects movie faking thing, and you do that live in the browser. I mean, this is pretty intense.
There's more than that. There's 3D visualizations and so on. We're actually using WebGL, not WebGPU at the moment. You mentioned that earlier on. We got WebGPU on our roadmaps. There's an awful lot of work happening to our engine, our 3D engine, which sits in C++. It's compiled to WebAssembly using Inscripting and then called by TypeScript. So that engine's undergoing a massive refactor right now in order to target Vulkan, DirectX 12, and WebGPU, because we're a cross-platform company. So yeah, there's quite a lot going on here. It's sort of complex data visualization, not just charts. This was a demo that was added recently. So we've got a geo map with all the earthquakes in the world shown over a heat map. We've got some financial specific demos, such as this one, which is sort of showing like a trading style chart for connecting to exchanges. We've got interactions as well. This is something that's super important, by the way. It's like, okay, you can draw lines on a screen, but can you select, hover, interact? Can you bind charts together? Can you have these kind of things? These are the things that our users are asking about.
So the cynic in me always sees this and says like, it's got to be fake. But you can open the console and probably see the data live, right?
Well, actually, everything here is the demos are all open source. So if you want to go and have a look at it, you can click on this little GitHub button right here, and that is not opening for some reason. That one will take you directly. Yeah, Law of the demo. I've got something blocking my mouse. Anyway, click the GitHub button. That'll take you over to our GitHub, and you can clone this repo and see all of the demos live. I mean, they can also be edited in the browser by clicking these buttons. We've got stat bliss, we've got code sandbox. I won't do that because it takes a while for them to boot up. So you can see how it functions,
So I mean, David, you said that they started in WPF and then it went to WTF, which is the web. Basically, how much did you learn from how comparable is that you worked in Windows only and then you basically said like, in this year we gotta go somewhere else. Is it frustrating to go multi-platform, or is it more of an interesting challenge for somebody like you?
It's a bit of both. I think, and we have this discussion a lot internally because we're now trying to move from, like at the moment, the different platforms, although they share this common drawing engine, there's a lot of platform-specific code at the sort of the charting layer around that, which is really there because a lot of what SciChart is about is flexibility and customization, and so we want to give people access to all of the sort of the platform specific stuff that they're going to use to customize things. So it's challenging to then say, okay, if you're going to have a truly cross-platform version, then where do you compromise on the customizations and allowing people to do that kind of thing? It's like on WPF, people love the fact that my axis is an actual framework element, and I can each individual axis label is like a text view, which I can customize to my heart's content, and I can click on it, and I can, we don't have that in JavaScript. But in JavaScript, the axes are rendered natively, and and it's actually way faster than the axis rendering and calculation in WPF. So there's these trade-offs. So yeah, obviously, like on mobile, you've got kind of native touch handling and gesture stuff. You know, as soon as you try and do, you know, you can take SciChart JS and run it on a mobile, and the touch kind of works, but it's not as good as native. So those are the kind of trade-offs that we get.
So you talked earlier about the 3D engine. A lot of other libraries are actually using a game engine and actually put a chart engine on top of that. Yours was specifically written for that purpose? Is that what's happening here?
It's sort of adapted from an engine, but yeah, from a technology point of view, it's very game engine like, and it's but kind of stripped down and with a lot of chart specific stuff in there for kind of optimizing all of the you know, the particular cases, you know, lines and columns and things drawn with shaders and all of this kind of stuff. So
there's one fundamental difference is that you know, a game engine. So you know, the obvious one that people think of is say Unity, but there's many game engines out there. People, you know, game engines are kind of tuned for computer games. They want to load a geometry once and then it's static, right? So you have this enormous map. Maybe you have a car, you have a character. There are some elements of those which are animatable. The character can walk. You know, the car's wheels can turn, and so on and so forth. But it's mostly static geometry. Whereas this is highly dynamic, and you know, when you're piping data into a chart, like you know, say one of these demos, and you're throwing more and more and more data, you're having to send that data from main RAM down to the GPU before you can even render it. So we had to make quite a lot of adaptations to make that efficient. You know, the immediate mode rendering is not something that GPUs were initially designed for, but they've come an awful long way and evolved. But yeah, I mean, at the heart of what we do, at the heart of SciChart, it's basically a C++ game engine or stripped down, super lightweight. The entire thing compiles into just over 1 megabyte in WebAssembly. You know, and that includes text rendering engines, it includes text shaping, as well as primitive drawing, you know, objects, immediate mode rendering, shapes, etc., etc., etc. And yeah, it's a cross-platform code base. The C++ compiles on Linux, it compiles on Mac OS. iOS, Android, and Windows. But for the JS version specifically, we're using mscripting, which, you know, super powerful tool, you know, and it outputs a binary and a bunch of bindings, which you can then talk to with JavaScript and TypeScript.
So one thing I'm completely, when I looked at SciChart, I'm just overwhelmed. I mean, I'm the kind of like illiterate person that doesn't know which chart to use for what use case. I guess you have a lot of customers that actually know what they want, and there seems to be a lot of stuff that's in there came from customizations for a client that then became part of the library, or do you come up with these own things? I mean, you talked about a wafer when we did the preview interview here, and I was excited because I thought about biscuits and cakes and everything. But like you have interfaces here that seem to be very bespoke for a certain customer, and then become part of the framework. What does that do, for example? What that looks like something I'm looking into.
Yeah,
a microscope.
I'll answer that question quickly before David you know, can talk a little bit about this demo. So we're very customer driven. I mean, you know, first of all, charts visualizations. This is not something new. This has been going back, you know, very, very long time. You know, there's many libraries out there that can draw 2D, 3D visualizations. So we're not necessarily inventing something new. However, when our users use the library, they are the ones who come to us. We must have answered somewhere in the region of 20,000 support tickets over the lifetime of the business. You know, we've got 4,000 or 5,000 forum questions. We get feedback in lots of different channels. You know, people say, hey, could you do this? Could you do that? Like this example, for example, this one is designed to be a demo that would be recognizable to someone in the semiconductors industry, which is the analysis of semiconductor wafers. David created this, and you know, we've got basically a heat map here, which is showing your wafer analysis, and then all of these charts are linked using cross filter. But it was customers that came to us and says, hey, we have this use case. This is what we're doing. This is what we're doing with your library. And sometimes it astonishes us what they are doing. We don't even know that that's possible with our library. You know, what the heck? How have you done it? And they say, oh, like this, like this. Could you help us a little bit? And, you know, so a lot of the knowledge does come from, you know, and the development, it really is driven from customers, you know.
I was wondering about the sort of technicalities of these kinds of charts and graphs, because they're obviously so specialized and kind of academic in some sense that, you know, there's graph types and chart types that I've never even seen, right? And there's plenty of them. So how do you kind of which order do you do that in? Do you go and speak to, you know, a specialist that you've got maybe in, or specialists, and say, can you give us the technicals of how this graph works and how it then interacts with the data? Because, you know, you'd obviously want it to be as accurate as possible.
Sometimes we do need that input. I mean, a lot of this information may be public domain. Like, for example, you know, talk about polar charts. You know, it's basically just a radial axis. This is something that, you know, many libraries implement. You know, so you have to go away, learn about that type of projection. Then you have to think about, how do we include this in the software? Because if we do a radial projection and a linear projection combined, in a polar, the X and the Y actually depend on each other. So you end up with some kind of weird circular loop. How do you introduce that to the library without messing up the existing code, without making it slower, without introducing bugs? You know, so there's a lot of work going into the software architecture to make it, you know, properly segmented. But sometimes the stuff that we've never heard of, like someone came to us and said, hey, can you do a Smith chart? Now, I actually studied electrical engineering, so I know what a Smith chart is, but I don't understand it. It's similar to a polar, but, you know, it's something to do with resistance and impedance. We haven't built that yet. And one of the reasons we haven't built it, we don't understand it. We need one of our customers who really needs a Smith chart, because it's been mentioned a few times, to sit us down and actually teach us what the heck this thing is, so that we can then build it. You know, that's an example of that. I mean, you know, sometimes we hear terms that we've never known ourselves. Like someone said, hey, can you do GeoJSON? It's like, what the heck is GeoJSON?
Oh,
like,
I know that.
It's a map. And I'm like, okay, so it's a map defined in JSON. Oh, that should be pretty easy. So yeah, we're learning a lot of stuff from our customers. We're learning a lot of stuff from the people that use the library, from feedback, you know, as well as developers that we hire. Like, you know, if we bring on a developer, you know, one of the guys we hired said, hey, I know an awful lot about D3 and cross filter and blah, 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 blah. And he's helped us generate some of these things, you know?
But I think the key thing is that the way that we approach these things is, if someone says, oh, I want like this kind of chart type, what we're then thinking is, okay, so what kind of drawing primitives, what kind of data reshaping and analysis is going to be required for that? And what's the sort of the full universe of possibilities that exist around that, of what you might want to do? And how can we give you sort of tools at various different levels that, you know, you could do that, but you could also do things around that. And so, you know, a good example of that is, so new in version 5, I mentioned these new axis types. If I can show my screen. Yeah, so this is discontinuous date access. So this is a very standard problem that customers, particularly in financial things, have, where you have date-based data, but you've got gaps in it. So you've got stock markets, for instance, only trade on weekdays. So you've got these kind of gaps in the data. And previously we had sort of like standard numeric axis, which would have had gaps in it. Or we had this category axis, which just says, okay, I'll just ignore the X value. I'm just going to plot by index, and that collapses the gaps. But it has all of these other problems. Like, you can't then have like series with different numbers of points, or like multiple values per thing. So we've created this new axis type where you specify a set of base values that determines your axis scale. And then you map your X data to that scale and then plot it. And it solves all these problems and gives you this nice kind of, you know, gap collapsing thing and all of that kind of stuff. But the principle there is much broader than just the this particular use case for financials. So this is the same basic idea, but without date values and without sort of like a slightly different version of the same idea. It allows you to have this crazy, completely non-linear access. So on the right here, we've got what looks like a logarithmic scale, but which smoothly goes through 0. So normally if you have a log axis, you have to like have a positive axis or a negative axis, and you can't have both. This is actually log linear. So like halfway between 0 and 10 is 5. And halfway between 10 and 100 is 50. So it's like, this is actually linear between these log scales, and it's smooth around 0. And on the x-axis here, we've got like, we're kind of doing a dynamic zoom. So we're kind of compressing or adding additional base values in around a point to sort of dynamically zoom the data. And I can drag this, and it's like, we're effectively zooming the axis at that point. So it's like putting a magnifying glass over that portion of the data.
You're seeing it on top of a ball, and that's basically seeing the flat version of that.
Yeah.
Let's see that, and that's the. I just think about Canvas development, and that's basically a bitmap with X and Y, and I'm like, oh my God, you have to do so much scaling in this case, and you think in the 3D space, and you have to somehow show it in the 2D space. So this is a lot of like math, and I'm just like, how does it perform? Because the idea of Canvas was, because it's only pixels, that it was really, really fast compared to an SVG engine or another engine that was basically vectors. But this is basically using WebAssembly for the math thing, and then rendering.
That's the really key thing, that we push all of the the data and the coordinate calculation down into WebAssembly, and we do it there. And that vector math is really fast, and we use a bunch of tricks to some pointer arithmetic and various other things to do that super fast. And we can, there's if you have a completely linear axis and your data fits nicely within kind of float 32, then you can actually offload that coordinate calculation onto the GPU. It's like you can set up a simple transform, and you can do the stuff there, and and that's we have that path. But we also have the path of, hey, actually my data really is 64-bit, and I really do have this big range and precision. And I want to keep that precision all the way down. So we've got this example where we're sort of pushing the boundaries of, okay, how far can you go? So this is standard kind of date time data. So if you have 1 millisecond precision in a standard Unix date time, you get about 70,000 years worth of data. So I've got 1970 here up to 70,000. And I can programmatically zoom in here, and we're down to sort of sub-millisecond precision. And if I start to scroll, it's a long way before we get to anything else. And if you think about what happens when you sort of zoom in on these kind of points, like once you're down at this level, the next point over here is like billions of pixels in screen space, out the side, and getting the chart to continue to render and allowing that stuff to continue to work at that level is hard. So if you go up to 1 second precision, you can get 1 billion years of data, or going the other way. If you're doing sort of highly scientific stuff, nanosecond precision, we've got 50 days of data. So again, you can zoom into this.
We were chatting about this yesterday, and that one of the challenges is that your timestamps, when you have them on the server, they're int64. So you've got 64 bits of precision to represent a timestamp. So .NET datetime has got 100 nanoseconds. Unix, it's got 1 millisecond. Other ones might have 1 nanosecond. But in JavaScript, you just have number. So number is 64-bit float. So you only have 53 bits of that float to represent the actual integer value. So your max safe integer is a lot lower than, say, you're using an int64. So when you take those numbers, you're immediately discarding 13 bits of precision, right? And if you're using WebGL or WebGPU only you're pushing the data straight to the GPU, you're discarding 32 bits of precision, right? So there's a lot of thought that goes into how do you trade off precision versus speed and get the maths right. I'm personally really pleased with this example because we knew we could do it, but like actually demoing it is challenging. And if you have two numbers, let's say you have two numbers and your numbers fit within number.maxSafeInteger, and then you multiply them together, all of a sudden you've got rounding errors, you've got precision errors, right? So how do you become precise? And we would find odd artifacts, like you'd zoom all the way in and then the chart would disappear. Or, you'd run out of precision and your labels are gone or something like that. So the amount of
label formatting was actually the hardest part of this.
Yeah.
Once in order to do these kind of ultra precision things, you have to have a start date and then an offset, which is in higher precision. And then you've got to combine those two things at a format. And one of the things that we're doing here on the label formatting is to say, okay, well, we can't have the full date on every label. It's too big. So we have like a wide format for the first one and then a precise format for the second one. And those formats change as you go in. And, doing all of that is really hard. And obviously, like just date formatting in JS is just hard anyway. So, we do some of that, but like the label formatter here also has a pretty good API. There's an example. This example is, okay, so if you want to customize this, this is another sort of similar example. We've got sort of big range of high precision data. This is using the date functions JavaScript library and saying, okay, let's just, we've got our own function here for customizing the wide format and the precise format, where using this function, we can now have like nice format strings, which is like, that's the way that you would want to do it, right? SciChart works very hard to not have any external dependencies. So, you're free to swap in whatever formatting library you're probably already using in your application. But yeah, these are the kind of customizations that we provide. And there's like, you can get really into the detail of or if I'm in nanoseconds, then do this, and if I'm in microseconds, then do this, and all of that kind of stuff.
In terms of the overall performance of the thing, how do you do that as a continuous testing environment? Like you have probably, you have special needs that come in and basically new things, but how do you make sure that there's no regression in a build that basically that the thing becomes much, much slower than it was before? Because there's a lot of complexity here. Like, do you have automated testing environments? When we talked earlier, one thing you said is like most people show one chart, but we have so many users that show hundreds of charts at the same time. How do you make sure that your performance stays with that? Like, do you have a script that punishes your library?
I think a lot of that actually comes down to my personal obsession and passion of writing high performance code. I was in university in 2003 and I was sitting writing. I had to write Fourier transform. I had to use a Fourier transform. I was sitting and writing like a super hand-tuned version of that in assembly. And my professor was like, "What are you doing? What's your problem? Just go and use something off the shelf." And it's like, "No, it must be faster." So my personal obsession is part to do with that. But okay, I'll tell you what we do. Yes, we have automated testing. Across the platforms of SciChart, Windows, iOS, Android, JavaScript. We've got to have somewhere in the region of 20,000 automated tests. We have visual tests as well, where we're booting a chart up with a certain configuration, screen grabbing it, and then comparing that expected actual. If any of those fails, we can't deploy. We're using CI/CD, as everybody should. In terms of performance, previously all of this has been manual. Like we would run this. We do have a performance test suite internally, but we would run that manually. We're in the process now of integrating that to our build. So there is a performance test suite, which is something that we've used for years internally and developed for years, but we've just gone ahead and published it. It's on GitHub. It's on the SciChart GitHub is actually called ABT software, and it's called JavaScript Chart Performance Test Suite. And what this does is it boots up the chart in various scenarios. So, okay, we're going to try one series with 1 million points, 10 million points, 100 million points. Then we're going to try 1,000 series with 1,000 points. We're going to try one chart. We're going to try 10 charts, 100 charts. We're going to try scatter series. We're going to try columns, mountains, candlesticks, heat maps, 2D, 3D. And even that, there's like 13 or 14 test cases with, between 5 and 10 sub-test cases per thing and so on. Even with that, that doesn't in any way near touch the surface of what our users are doing, right? They are doing insanely complex stuff. One of the members of our team wrote, very, very talented guy. He wrote a number of things. So he wrote a memory debugging tools, right? Which our users can enable memory debugging, and it will tell you if you have WASM memory leaks because you forgot to delete something. He wrote an internal a replacement for malloc so that we can run that in a debug build. If we're leaking memory, it will tell us you've allocated but haven't deleted. And he also wrote a bunch of performance mark stuff. So dotted throughout the code, there's performance marks where we will log out to a in-memory logger. I'm starting the operation of measuring my text labels, and now this is how much time was spent, for example. Because as you mentioned, complexity, right? It doesn't do it justice to throw up a single chart with a bunch of data in a line series and say, look at how fast this is. It doesn't do it justice. What if you have...
It's not quite ready yet, but hopefully very soon. We've got a thing which takes all of that performance mark data, records it, and then dumps it into an application which displays it as like on a profiler trace. Which is, but it's sort of chart logical. So, I mean, Chrome and Firefox have great profilers for sort of digging into your individual calls and things, but they don't allow you to then separate out, like which series is it that is, being slow.
Does the render?
Like
it does the main rendering. Yeah.
So this gives you the rendering from a SciChart point of view of like, okay, so this is my surface, and these are each of the series, and these are each of the annotations, and this is the setup and the draw and the etc. And allows us to, we've used that a lot in sort of, as we kind of fix one performance issue, then sort of, something else will rise to the top as to be the next thing.
It can be weird stuff as well. Like we did have a performance regression during the testing of this release, where one of our test cases, where you have 1,000 series on screen, was half the speed of what it used to be, but everything else was perfectly fine. And we were like, what is going on? And it turned out that there was a per series transformation and clipping step that was being done. But if you have 1,000 series on the chart, it was being done for every single series when they're all displayed in the same viewport. So once we found that, the optimization was simply like, okay, if they're in the same viewport, then we only need to do that once. The level of granularity to find that though, it's pretty tough. Hence the tools that David's been talking about. So.
We have a question from an audience member, which is cool. There's Mahmoud Uzreal. I'm building a trading model that mimics a bot workflow, heavy SciChart user. It's like vibe coding for trading. Scrape, learn, build, backtest, visualize, all running locally. Any tips for better using?
All right, so SciChart JS, we actually have this library called SciTrader, which is on iOS and Android, and we built that, I don't remember exactly when, it was maybe 4 or 5 years ago. And there's even an app on the App Store called SciTrader, which is a demo app. So this is kind of like a fully featured trading chart that connects to an exchange, and it's got indicators, adding and removing indicator panes, and behaves a little bit like TradingView, that kind of thing. Now, on our roadmap is to port that into JS. In fact, we paused it recently because we were furiously working on SciChart JS version 5. But we want to port in SciTrader iOS, Android into JS, giving you a fully featured stock chart, right? The new axis type that David talked about, the discontinuous date axis, I would absolutely recommend to use that axis and not the category axis or the numeric axis. And the reason why is that it will collapse gaps in stock market data, like overnight, weekends, but it also has the flexibility of letting you have lots of different series. So we do have pretty much on our roadmap for the next couple of months, we do have a lot of items related to trading charts because it gets asked a lot, and hopefully we'll have some better stuff out soon.
Yeah, all the complex drawing tools and all that kind of stuff. To that question, I would also say one of the big things that we learned in the V5 process, the thing that started it all off actually was a question from a user about how do I read back data from the data series. So I've put my data into the chart, but I now want to read it back in order to do that. And we discovered that the standard bindings that Inscription gives you for get a value from this array that's in WebAssembly is actually really slow, because every time you do that access, it creates a new array view around it. And we discovered that if you just create that view once and then access it, it's like 100 times faster. So we now have these functions vector to array view, which sort of simplify this process and give you these array views, which are it's like accessing unsafe memory, right? If anything changes in the chart, those views are invalid. But within a single JavaScript, single threaded, which makes everything easier. Within a single loop, it's all pretty safe. So and it makes it easy to sort of get a copy of your data back out. To make use of that stuff to do that kind of analysis. There's a few demos in here which show examples of that. So for instance, like the filters one, filters.
Use the search, David. Use the search.
Filters.
And also, why wasn't it on dark mode? That's disappointing.
Yeah, yes. I saw you flinching earlier, but it shows that you're.
Yeah, I'm blinded here.
That's pretty good. Yeah.
Yeah. So this is like a custom filter, which is sort of code that runs on top of a data series. So I'm piping data into my data series, but then there's another thing which is saying, okay, on every append, do this transformation and add it, and this one is sort of doing this aggregation, and these kinds of things can be made massively faster by using that efficient kind of readback. Similarly, for doing paletting and stuff like that. So it's possible to do this stuff, store all your data in WebAssembly, but keep the high performance.
Cool. I mean, we got so much features here. We got an hour that we actually finished already. So let's go back to our main scheduling a bit so you can calm down and actually not go there. If you haven't seen SciChart yet, take a look. The documentation is incredibly detailed. There's so many demos. And the other thing, of course, which I like is that it's free for non-commercial use. You can actually try that out yourself. If you look at the pricing of the other bits, it might be steep, but then you see just how much of a professional tool this is and how much of your end users are actually companies that rely on that kind of information. I'm a bit confused about the randomness of the pricing numbers, like £123.22.
Personal bugbear as well.
Did you do that so it shows cool on a chart, or is that the idea, or
it was supposed to be demonstrating what is this costing me monthly, right? So when you talk about pricing a value, it's a difficult. How do you price something? It would be cool if this was open source and free and everybody could use it. It would benefit the world, but then we wouldn't have the funds to develop it and maintain it, right? So choosing a price point is very, very tricky. We are actually discussing internally what we can do about tidying up the store, making it clearer. What kind of adjustments for pricing to startups. We get startups come to us and say, do you have startup licensing? At the moment we don't, but to give you a little comparison here, sometimes the startups that come to us that ask for discount pricing, their seed funding is bigger than our all-time revenue. So we are a small independent business. We're here to make a living. We're here to do a good job. We're here to serve our customers as best as we can. And obviously we all want to make sure that it's fair to the community as well, right?
You make that mistake. You're not calling yourself an AI company. That's how the seed funding comes in.
Oh gosh, we would have been millionaires by now.
Maybe just rename it to SciChart, like SCAI chart.
Yeah, I like that.
Yeah. That might do it. Yeah, the .ai thing. So let's finish off with some fun thing to do. We have a new thing in the show here where when I collect things for our newsletter, I look at like headlines and which ones are fake and which ones are new. So I want the three of you to actually take a look at some of those and say if it's news or if it's fake news. So let's take a look at that. All right, let's get started. The first headline: Apple developing AirTag-sized AI pin with dual camera.
I haven't heard anything about this. I got no idea. I'm gonna say fake, but it kind of sounds real.
This is the problem.
Yeah, that's got to be real.
No, fake. Fake. I haven't heard anything about it.
It's news.
What?
Yeah. So you cannot look at people anymore without being recorded in the future. It's just like any button could be a spy device now. Decentralized AI marketplace launches token to reward dataset contributors.
True. That sounds like something somebody linked to Cloudflare might be working on. I don't know.
I wish it was true, but probably not.
I'm going to go with true as well. It sounds crazy. How can we tell in these days?
Fake.
Oh my gosh.
Blink and you'll miss them. 6-day certificates are here. This is about HTTPS HLS certificates.
Yes, I hope so. That's a good idea from a security point of view.
Fake. The way it's written. Blink and you'll miss them. No, fake.
It's news. These things happen. These things are available now. And it's got nothing to do with the Blink engine. So that's the other thing that confused me there. Okay, why is next not working? Student arrested for eating AI art in UAF gallery protest.
How can you eat an AI art?
I'm going to say real, though. I don't know how, but
I'm going to go for
so
real
mad.
as well, just because it's so mad. It's so mad. It's got to be real. Let's see.
Yep, it's news.
Oh,
Somebody ate a picture because he wanted to say I'm an artist, and computers shouldn't do that. Ukraine to start share wartime combat data with allies to help train AI.
I'm going to say yeah.
Yeah.
That sounds real, doesn't it?
Yeah.
And it's news, yeah.
Yeah.
We're doing
Burritos from heaven. Are drones the future of delivery?
real.
I think that's a real story, but I'm not looking forward to that future.
Yeah.
I'll just be like,
do you know what? I hope so, but I think this is going to be a lot further off than we hope.
Yep, it's news. There was also another great news piece where stray cats in San Francisco actually started to write the delivery robots and actually send them in wrong directions and stuff. So it's interesting what's happening in this space. Furious AI users say their prompts are being plagiarized.
I'm going to say that's real.
Definitely.
yeah, probably real. What a world. What a time to be alive.
Yeah, it's news, and it's so weird because, the AI data is probably stolen, but their prompts are being plagiarized. Okay.
Wow.
Startup releases automated tool to re-platform legacy monoliths.
Yeah, I think it's real, but I don't see how they're going to do that. That sounds so complicated.
Yeah.
Using AI.
I think we all wish, but no.
And it's fake.
Yeah.
Oh, thank goodness.
Spotify is testing a feature that syncs physical books with audiobooks.
I think that's real because I'm pretty sure it's called Whisper Sync, and Audible's had it for about 10 years. So I'm going to say that's real.
Interesting. I would have said no, but okay.
I got no idea, honestly. Go on, let's see.
It's news, and I have no idea how they're going to do it. Is there a robot that changes your book around when it hears the sound, or
using the Apple AI pin that can see what page you're on?
Oh, sure. Yeah, and that was Faker News for this week. So you can play that along on the website as well. And yeah, it's fascinating what's out there. And yeah, thanks so much for being part of the show. This was again really interesting. I think it's overwhelming when you look at SciChart compared to other chart libraries. But I think it's a matter of take a look, because what I always found, people don't know how scaling works. You find a solution that does the thing for you, and then out of a sudden you got one customer that comes with 1 million data points, and you're like, okay, what do I do now? what is your goal with this? Like, who do you want to actually reach? I mean, you have a lot of customers that come up with interesting things to solve, and as a developer, that's always what I want to do. But who are the people that you're missing out on right now that you want to have a play with what you do, and what kind of feedback are you looking for?
I think that, you know, it's one of the things that we're the most proud of is the types of applications that truly are pushing the boundaries of science and technology. You know, so there are apps out there whereby people who haven't heard of us or haven't tried these kind of solutions, you know, they may be thinking, well, this isn't possible to display this much data, so we're just going to change our requirements. You know, or maybe it's not possible to have this much complexity and interactivity. But there are apps out there that are used in sort of medical community research, you know, scientific research as well, where we have seen the boundaries of technology pushed an awful long way just because they can visualize what they wanted to visualize. You know? So that's the kind of thing.
Yeah. There are diseases and conditions out there that are being treated right now because people are making use of these kind of visualizations to improve them. So
it sounds a bit far-fetched, but we have had customer calls and we've seen the kind of things that our users are doing, and it is absolutely happening. You know?
Yeah.
Cool. Any last words you have for our audience out there? Like, David, what do you think people should be doing?
Build bigger charts. It's possible.
Do something crazy. And also, just to thank you guys for having us on. Thank you so much for the time. Really, really appreciate it.
Welcome. Dan, anything from you?
Yep, I'm going to go and have a look at GeoJSON. So thanks for that. That's I googled that in the background, and that looks like a lot of fun. But also, yeah, just to say, go and check out SciChart and play with those demos, because even if you're like me and you don't have a scientific background, they're a lot of fun to play with. So yeah, thanks for coming on the show and telling us all about it.
Thank you, guys.
And I've got a fun learning to share. I learned that vegan cheese in French is called fromage, and that's just wonderful.
Lovely, lovely.
And that's it for today. So thanks very much for the show, and thanks for David and Andrew for being our guests. And we see you next Wednesday, and the recording is out soon. You can also play the Pago News if you want to. And yeah, we're going to prepare for the next show then immediately after this. And you go and see if all your builds worked, and good luck with any of the releases that are coming in the near future. Thanks very much for watching.
Thank you. Bye.